revolution of economics, politics, and government. Welcome to the blockchain.
Our next speaker, he currently oversees the development of Millennium's core technology layer, which forms the foundation of all Millennium products. He has over 15 years of experience in service billing systems, search engine technology, and capital market systems. And he's currently working as the Vice President of Technology at MilleniumIT. I'd like to invite Mr. Tharindu Dissanayake to speak on blockchain hands-on.
Hi guys, the name of the presentation is Blockchains Hands-On, but we are not going to do any hands-on work. This is going to be just me rambling about some of the hands-on work that we have done on blockchain. And later on you will see there's a little demo system over there. The guys who built the system are here, so after the event you can actually go and play around with a real app built on Ethereum. Okay, so this is my entry into blockchain. Some boss coming and telling me there's this cool thing called blockchain, let's build something on it. My previous boss is here. Luckily, the current one is not in here, so it's all cool. But this is sort of a describes where we are in terms of trying to understand blockchain and actually try to build things on it. There's so much talk about it. There's various people understand blockchain in various different ways, and everyone wants to sort of get into it. Okay, so first thing that you have to say to your boss when he says, build me a blockchain, of course, is not to build a blockchain. First thing would be to select a proper platform. So as you've heard with all the other speakers, there's so many things involved, right? There's cryptography, you have distributed computing, networking protocols, keeping the ledger, doing all those things. You don't want to do any of that if you want to just build an application on top of a blockchain. So there's a lot of platforms or fabrics out there which you can use in order to build applications on blockchain, right? So these are some of them, but there's lots more. So the next question that you would have to answer is obviously public or private. There are public blockchains where there's so many other people are also on it. There's different applications on it. Do we want to build our application on top of that, or do we want to build our own private little blockchain and have our application run on that? Okay, so there's obviously, in terms of deployment, there's differences. If you go the public path, okay, there's more nodes already there, so there's more security, it's open, anyone can join, so essentially anyone on the blockchain are potential customers. If it's private, of course you don't have to play by the rules of the network, you can make up your own rules, so it's flexible. You can permission it saying, hey, only these guys are allowed in on it, others are not. It has better privacy because you can control what you can put on the blockchain, or rather you can control who have access to that content that you put on the blockchain. Unlike in a public network, you put it on, everybody can see it. Okay, and in certain cases it can be faster because at compromising some of the security aspects, you can say, okay, I don't need all 500 nodes to agree on what the next block is. I have these three guys, one of them will decide what's the next node needs to be. So that decision can be made faster. So platforms like Rubix, Aries right now it's called Monax, are platforms like that. Microsoft has on the Azure cloud, you can get VMs that have sort of a blockchain template in them. Streamco, multi-chain, all can be used. On this side, you have obviously the Bitcoin public network and the software stack. Same thing with Ethereum. There's a public network and a software stack. That doesn't mean you can take Ethereum code base and spawn off your own blockchain, right? We actually got a single miner blockchain running on that laptop over there. So Hyperledger and Ripple are, it's somewhat of a somewhere in between private and public. Ripple, the network is public, but the actual software is closed sourced and permissioned, so it's somewhere in the middle. Hyperledger is also, it's right now there's no public network, but the domain and the applications that it's been used for, we might see something like a public network in the future, but right now it's more on private things. So, I mean, we've talked about things like that throughout the first 3 presentations. So, I'm just going to talk about 2 projects that we have done. Yeah. So, first one was on Ethereum. The word smart contract kept coming up as well. We'll touch on that later on if you guys have any questions on it. This is what Ethereum project describes itself as. Right? So it's a platform for building decentralized applications that can't be censored, that can't be stopped, can't be turned off, essentially. So think of, so the closest explanation would be you can think of the Bitcoin blockchain, Bitcoin network as sort of a world currency, and Ethereum network as a world computer. It's not just currency, you can have various other things, and you can store programs and execute on it as well. Okay, so the actual project actually started off of a DEA. One of the guys said, okay, what is this blockchain? We are going to put our blockchain and automate our cafe. So at our cafe, you line up, buy stuff, you pay, or you can sign off, put your employee ID, sign off a little bill, and it will get deducted from payroll. So this came up initially as a joke. Then later on, it was no longer a joke. So what we actually try to do is, okay, let's take this use case. Let's actually try to build something around it so that we can get some experience doing hands-on work on blockchain, right? So the idea was that, okay, you can go up to the cafe, order your meal, tell your employee ID, that guy will enter it into their system, which is okay, LED screen, so can't point. Doesn't really show up. So it's the vendor, he'll put in your employee ID, put the order, and then suddenly on your mobile phone, you'll get a message saying, you just ordered these things, is it correct? Confirm. So you press the confirm or cancel button. If you confirm it, you make the payment for your meal on a blockchain, right? And the vendor application is also looking at the blockchain to seeing, okay, did you make the payment? Okay. So what we are using on the blockchain is, again, it's based on Ethereum, so the currency is Ether, but the Ether that we use is different from the Ether that's on the public network. Our Ether is worthless because it's our own private network, right? So it's just used as a token. So what we do initially, basically the idea was we pay with this token, and the end of the month or end of the day or end of the week or whatever, the cafe operator can take all the Ether that he has collected in his account, transfer it to the finance guys. Finance guys will look at the blockchain, look at who had made those transactions, and deduct it from the payroll. So no cash involved, and of course I can't go and tell someone else's employee ID and get him charged for what I eat. Now this diagram actually shows you how we would have built it without a blockchain, right? So First one would be like, okay, there's common application, common database, everybody uses it, system works, right? But the problem is everyone would need to trust the system and the database, right? So in this case, if the finance guys are running the system, everyone needs to trust it. If the cafe operator comes and says, hey, I don't trust you guys, I want to keep my own records, sure, you go to the solution 2, where he has his own application, own database, he trusts that system, but so now you have, okay, at the end of the week, you have these records and the other records from the 2 systems, you need to reconcile, there will be mismatches, project managers saying, hey, this guy is not in my project, why am I being billed, all sorts of things, right? So instead, this is what we have on the blockchain. So so initially what we do is we spin out a blockchain, all the users get their own accounts, and also the initial version or the genesis of the blockchain also has an account for the finance guys that has, say, 10 million Ether, right? It's worthless, so 10 billion for that matter, right? So what you can do is, I can go and tell the finance guys through the application, okay, I want 1,000 Ether transferred to my account. No problem, just 1,000 tokens issued to me. Okay. So when I go and make order something, again, the vendor is going to put into his system my employee ID, which maps to my account on the blockchain, and I'm going to get a message. Now that messaging doesn't work on the blockchain, it uses a different app, uses Google's cloud messaging to get a message popped on my phone. Okay? So I respond to that by saying, okay, I either accept or reject. If I reject, I just give him a message saying I didn't order it, that someone else rejected. Or if I'm accepting it, what I'm going to do is, I'm going to tell the blockchain, hey, take this many Ether, the token, that I need to pay to the cafe, transfer it from my account to the cafe's account, right? And I initiate that transaction on the blockchain. Right? And as soon as I create the transaction on the blockchain, the blockchain is going to give me a hash that identifies that transaction uniquely. So I have a hash that tells me what the blockchain is going to call this transaction, and through my app, I'm going to report that transaction hash to the vendor. So the vendor is going to see, hey, this guy accepted it. He says he made the payment through the blockchain, and that transaction has this ID. But he's not going to trust, or the payment hasn't really completed. So the mining nodes running on the network is going to pick up this transaction in a little while. In this case, it's Ethereum, so a block gets mined within 15 seconds. Right? So unlike Bitcoin, which the average mining time is 10 minutes, on Ethereum it's about 14 seconds. Right? So it'll pick it up, mine it into a block, add it to the blockchain, and as soon as it's mined and added to the blockchain, the vendor is going to see, okay, the blockchain has confirmed that transfer has completed. Okay? So he's going to be able to see it in his app, okay, this guy accepted, okay, blockchain also completed the transaction, and he's going to give me my mail. Right? So one important thing that we've learned here is that for scenarios which require quick response, immediate confirmation, the blockchain's mining times are not ideal, but there are ways around to work with it. But in this case, we are talking about 200, 250, that kind of rupee value transactions. So the amount of trust that you need to place is different from whether this was a $100 million transaction, right? So if the blockchain says, okay, the payment is confirmed, you can consider it as okay. It might change within the next 60 seconds because some other block got mined and we forked into a different chain. but the risk of it is, in this use case, would be acceptable, right? And at the end of the week or whatever, the vendor can take do a transfer from his account into the finance account. Finance can track all the transactions that batch contains, figure out who made the original transfers into the vendor's account, and then update the payroll system so that based on that, your meal payments get deducted from your salary. Yeah. So we've got a demo that would show you the client and vendor part working on that. The blocks here as EVM nodes would be the Bitcoin, or rather Ethereum nodes that forms the blockchain, the fabric of it. So if I don't trust my company or the vendor, I can run my own node on the network. Right? It's going to cost me power, but yeah, but I can do that. Okay, so the next one is actually on Hyperledger. So Hyperledger, it's more designed towards businesses. It started with the digital assets, blockchain implementation being made open source. This is now driven by the Linux Foundation. All the big boys are part of this. Intel, IBM, Accenture, BT, big banks, big brokerages, big technology firms, they are all part of this. Actually, Millennium's parent company, London Stock Exchange Group, is also contributing to this. We have our advanced platform engineering team actually contributing code into the blockchain fabric. We also have one of our engineers as part of the Hyperledger's technical steering committee. So we are sort of invested in this. So what we have done with this, or the advanced platform engineering team has done with this, is this is relatively, Hyperledger is relatively a new project, started in 2015. So now, right now, it's in a stage where the people who are involved in it are taking it and building up reference implementations. So this is one such reference implementation built for trade reconciliation between the London Stock Exchange and the London Clearing House, LCH. So what happens usually is that at the end of the day, the exchange puts out or reports trades. So throughout the day, you'll have a real-time channel that reports trades. At the end of the day, you'll put an end-of-day file that says, okay, these are the trades that happened. And the clearing system would take it, do various validations, and you need to also reconcile it with various other information. Right? And that reconciliation process is going to throw out rejects. Now, getting those rejects cleared is sort of manually intensive or very different from one exchange to another. You might actually do it online or create a file, transfer it back, get updates, go through a very different process from one exchange to another. So the problem that's being solved here is that instead of the trading engine reporting it through a fixed protocol channel or end of day file, it gets reported onto a blockchain. And the clearing system would pick these reported trades from the blockchain and do its validation and reconciliation. So the setup is slightly different from a Bitcoin or Ethereum kind of a setup, whereas this is sort of details of how the system would be seen as from the guys who are reporting the trades and the system seen from the guys who are clearing the trades. So for the guys who are reporting the trades, it's essentially I report my trades in batches. I can at any given time go and ask, okay, what happened to this trade? What happened to this batch? I submitted this batch. What's the diff of the submitted batch versus the reconciled batch? So you can basically get various information out of the system as to I reported these trades, what happened to them. The interesting bit is the logic that does the reconciliation is actually embedded in the blockchain itself. Right? So in Hyperledger's terms, the smart contract bit is called chain code, or code that's on the chain. Right? So you have a chain code application running on the blockchain itself that does the reconciliation and provides an API to both the trading side and also to the clearing side. Right? And from the clearing side also you can pick up batches, do various validations, update them, and so on. So this is right now in the venue side of it has finished reference implementation. It has gone through a POC. The clearing side is right now on track for reference implementation. Okay, that's it. So I'll end with another Dilbert. Thank you.
Thank you, Mr. Dissanayake.